Hi everyone, my name is Vida Kamila and I will be introducing to you to our project. So, we have to ask, what is the problem? Well, we found that some of our classmates have difficulties understanding concepts in our syllabus. And with research, we concluded that they find the urinary system of humans in Chapter 13, Subtopic 2 to be difficult and hard to visualize due to its complexity. So, how did we solve this problem? We came up with a solution to build a model of the nephron to help students visualize the formation of urine. It is a working model that shows the pathway of urea in the nephron before being removed in the form of urine. We hope that by making this model, students will find it easier to understand and remember the pathway of the formation of urine in the nephron.
Alright, I'm Vaishnavi and I'm going to talk about Sustainable Development Goal SDG on a working model project, which is the nephron structure. So, the SDG chosen for this project is Goal 4, Quality Education. This goal ensures equitable and inclusive quality education and promotes lifelong learning opportunities for all, meaning that all children have equal opportunities to access quality education.
Now, I will explain on how we built this nephron. So, first of all, we use a water pressure pump represent as our heart, which will make the blood flows through the arteries. And as you can see here, there's a lot of small pieces of plastic which will represent as the large molecules in the blood plasma, such as red blood cells, platelet, and protein plasma. Now moving on, we use a big pipe as the renal artery and a thin pipe as the afferent arterioles and efferent arterioles. As for the Bowman's capsule, we use a funnel that have the thin pipe in them, which represent as the glomerulus. For the proximal convoluted tubules, the lobe of Henle, and the distal convoluted tubules, we use a medium-sized pipe. And here, you can see a syringe with a needle, which represent as substances that are need to be secreted from the blood capillaries into the tubule. And at the end of the tubule, there's a big pipe which will represent as the collecting duct. And last but not least, the thread will represent as the blood capillaries.
We will start with the first part of the nephron, which is the glomerulus. The blood will enter the glomerulus through the renal arteries, and the blood is under a high hydrostatic pressure. This high hydrostatic pressure is because the diameter of the afferent arterioles is bigger than the diameter of the efferent arterioles. Due to this high hydrostatic pressure, the content of the plasma blood will be filtered out from the glomerulus into the Bowman's capsule, except for platelet, protein plasma, and red blood cell, which are the larger molecules. And the fluid that is in the Bowman's capsule is now called filtrate, and this process is called ultrafiltration. Now, moving on to the proximal convoluted tubules. So here, the process of reabsorption occurs. Substances such as sodium ions are actively pumped into the blood capillary network, and chloride ions are passively absorbed. The reabsorptions of 100% amino acids and glucose also occurs through active transport. And the movement of dissolved substances into the blood capillary network will reduce the concentration of dissolved substances in the glomerulus filtrate, but will increase the concentration of dissolved substances in the blood capillary network. As a result, water will enter the blood capillaries by osmosis. Okay, now we'll move to the lobe of Henle. So here, The loop of Henle has descending limbs going down and ascending limbs going up. So at the descending limbs, it have a lot of upcurrents which will make it easy for water to travel through. So here, water is reabsorbed by osmosis because the renal tubule is more hypotonic than the blood capillaries. At the ascending limbs, mineral salts such as chloride ions and sodium ions are also reabsorbed by active transport. As for the distal convoluted tubule, the process of secretion occurs. So here, as you can see, there's a syringe with a needle that will represent as the substances that are need to be secreted from the blood capillaries to the tubule. So the example of the substances are potassium ions, hydrogen ions, toxins, urea, and even some drugs. So these substances will get into the filtrate and flow to the collecting duct. So secretions will regulate the pH level by secreting the potassium ions and hydrogen ions and remove the toxic waste. Finally, when the renal fluid reaches the collecting duct, only a small amount of salts are left and most of the water has been reabsorbed back into the bloodstream. So the remaining fluid is now called urine, flows down the collecting duct, and here a small amount of urea will be diffused out into the blood capillary and the surrounding fluid due to its small molecular size. So urine contains water, urea, sodium chloride salts, and uric acid and the creatinine. So after leaving the collecting duct, so urine flows through the ureter, bladder, urethra, and is finally excreted.
Well, now we'll be talking about the SDG based on nephron working model. Why is Go4 quality education suitable for this invention? Equity in education can be achieved among students, which is related to SDG 4 by this invention. Educational equity means that each child receives what they need to develop to their full academic and social potential. As a result, slow learners get to understand the process of a complicated structure faster by studying through the working model. The importance of this goal to the development of students in understanding this model is that it ensures that all students feel more relaxed because no matter where they stand, they get to understand the topic faster and easier by referring to this model. This model avoids students from giving up for not being able to understand a complicated topic. Slow learners will be at ease as they won't be left out either.
Based on the pie chart, we can see that the percentage of Form 4 students that had attended the Carnival STEM was 30.4%, while for Form 5 it is 69.6%. From what we can see here, most of the students were able to gain a better understanding or refresh their memories about the nephron structure. Based on this graph, we can see how well the students understand about this topic. This tells us that our invention was able to help students visualize the nephron structure, learn more about health issues, and understand the process of a urine test. Overall, I personally believe that the invention has achieved its objective, which was to help students understand this topic since it has been known to be a difficult topic in our syllabus. Therefore, I personally think that the working model of the nephron structure has been quite helpful, especially for those who have had a hard time understanding this topic.